Swayam Prabha. Digital India. Educated India.
Okay, so now we will move on to looking at resource constraints in the network logic. Okay, so I have actually shown a bit of the constraints which I want to use, and I want to discuss this a little bit before I actually start. So we have the same network. Now all I have done in this is to say that activity 6 can start only after the resources from 3 have been released. Okay, because 3, 6 and 9 are piling. I am saying I need a piling rig. I can only start 6 after 3 is complete. I can start 9 after 6 is complete. Okay, similarly I am assuming all of this, like 4, 7, 10 need the same crew, 5 crew and equipment, 5, 8 and 11 need the same. So I am just assuming symmetry and putting this through. Now do you see anything in this network which you would change?
These become redundant.
Right, the blue arrows become redundant. Okay, so what do we mean by redundant? So for example, we are saying here that we know that piles have to be cast for 6 to be done. We know that once 3 is done. So actually I am having the influence of 1 through 3 and 1 directly. Is there anything analytically wrong with this? If I do a forward pass based on this, is there anything analytically wrong with having redundancy? I will have to take the maximum.
So you would want to keep only one. I mean, if there is a particular sequence, when you say that 6 follows 3 and 9 follows 6.
So this is the alternate with redundancy is removed.
Yeah.
This is the network. This is with redundancy. Okay. Now, will my analysis change with this? If I have this versus this, will my analysis change?
When you actually do it, the early start, you're
looking at the maximum.
Maximum. No, it won't. It doesn't matter.
Okay, it really will not change. But when you have redundancy, your calculations increase. Your network complexity increases. Okay, the number of relationships are more, and it becomes difficult not only for the computer to handle it, but if you are trying to decipher the network, there's just a lot of relationships around, and it becomes more difficult. Okay, so you can check, and see if there is any change in relationship and any change in analysis due to the relationship. But you will find that if we start defining relationships with redundancy, there's just a lot we can continue to keep defining in a real project.
Sir, if like activity 1 is so large that 3 is very small, like once you get this resource, like getting the resources so large than placing them, then it might affect 6 also.
In what way?
However, no matter what you do, if
after 1 is
completed, 3 should complete.
So by saying that 6 will start only after 3 is complete, and 3 will start only after 1 is complete, makes 3 the controlling factor. Okay, so now if we take this network, so now you can see compared to the earlier network, there is a lot more zigzag in this. Okay, the relationship is flowing in different directions. So let us put this network up and try and solve it. I am tempted to have to do this, otherwise it's going to run into trouble. Okay, I have my start as earlier. I have 2, I have my 1, I'm not going to do this, I'm taking out. Earlier I had the 6, this time I'm going to have the 6 come from 3. Okay, now I go. So this was the piling, this was the pile cap. I'm going to do this in a different color again. Is this redundant? 6, 3, 6, 7, 3, 4, 7. Think about it. Okay. Okay, so now my relationship between 6 and 9 is also a resource. Okay, 9 and 10 is the physical. Okay, so 11, this is up to the abutment. Again, 8 and 11 is a resource driven relationship. My 2 and 12, this is the place beam on the east side. Okay, it requires 5 and 8. Okay, the crane that is going to be used there will be released, and then I will only then I will be able to do 13, which is placed on the west side, which is now 8 and 11. Okay. Earlier we had a 2 to 13 relationship. Is it needed? Not needed this time. Okay. Now once I do this, I can place the deck slab, but I have only one crew. I have to place the deck slab on one side, release the crew, and only then the deck slab can be placed. I had a 14 to 16 relationship, not required again. Okay. So I have got rid of these redundant relationships. Okay, what about my 8 to 13? Unless if I am doing 11, it means.
So it's not required. 8 to 13 it's
not required, because if I am finishing 11, it means I have finished 8. Okay, so this is a relationship is also not. So as the network gets more complicated and as you start bringing resource flows into it, you will have to look out for redundancy in the process. Okay, durations are the same. Okay, we have 15, 20, 12, 8, 36, 6, 7, 27, 12, 8, 36, 7, 7, okay, let's go through the 0, 0, okay. So we go through this path. Okay, this is the So you can visualize this. This is the east side. This is the first side to get all the resources. Okay. So we are going to go through with this without. Yeah. 35, 71. So now this starts at 27, 33. Now I have a predecessor here. Oh, did I?
That's 35.
Okay, so now this is controlling. 35, 42.
42.
Yeah.
Right.
42.
Now what is 8?
8 will be 71.
71. Okay, it is going to now be 71 because it's waiting. So what does this imply?
70.
That means the pier is finished. I mean, sorry, the pile cap is finished. It's waiting. It's waiting for the crew from the abutment to come and finish this. Okay, 71, 98. Okay, what about here? So we are done with this. Now we are waiting for, okay, so 12, I can finish 12 now, right? Okay. What was the duration we got in the earlier project? 118. Seems to be something which is changed here. $33, $45. So now 45, 42, 45. 134. Okay, and here we have 134, 141. Correct? Yes, 141. So this was so now we have 105, 141, 56, okay. So is the critical path obvious? How does it go? I mean, when you compare it to the earlier case, we could physically see how the critical path went. Here we start with, where are we? Should we do the backward? So we go through 1, 3, from 3 what happens? It goes to 6 or it, wait, 35, I think it goes to 4. Actually we should do the backward pass, but let's try to make a guess if we can see. Look at this, 35 is controlling here. So it goes through 4, comes down here, okay, and here what is controlling? No, let's start from here. Okay, we go, this 156 is controlled here, okay, and this 141 is controlled here. 134 is coming from here, okay, 98 is coming from up here, okay, and this is coming from 71 coming from up here, 35, okay, going through this. Now yeah, here there's float, here there's float, okay. So the actually critical path goes this. So it at a certain stage, it crosses from one side of the bridge to goes all the way across, and this is happening at which physical requirement?
After completing
The abutments. Those abutments are what is? What is time consuming, and they are resource hungry. Okay. Now what I'm suggesting you do, so we have got the critical path. You will be able to find that. I want you to do the calculation on the floats, okay, the various floats, and when we start the next class, we will briefly discuss the values you got and issues like how can resources be managed. It's just a broad discussion. We have a separate lecture on resource management and resource allocation, but how can resources be managed and how do we actually do what we want to do on a project with this. Just out of curiosity of management, which network do you prefer? Why?
We can manage, with better resources we can complete it earlier.
So there's more realistic.
Look at the duration. Look at the duration. What was the earlier duration? 118.
63 days now.
Right? So it's a lot more days because your resource constraints. Acceptable. Okay, so now again we start. Now here there's a lot of what do you call opportunity for parallelization if you want to bring the duration down. Now what if 181 days is not acceptable?
You have to get more.
You have to get more resources, or can I do, there are many ways you can do. In fact, we are assuming only one shift of work or something, you do multiple shifts with same resources, things like that. And okay, I'll actually take this up more for discussion. There are quite a few interesting patterns in this network. Okay, for example, you'll find when you get into float, here you have, in the other case, how many activities are critical? Almost all were critical except for a handful. Here there's only what, 1, 2, 3, 4, 5, 6, 7, 8, 9 critical. There are quite a few off the critical path. 1, 2, here the critical path is not, so after I actually get my east span placed, of course they gets critical, but for example this deck then becomes non-critical. Okay, so there has to be a very close management of the network to understand what's critical, what's not critical. If we accidentally, or in one of these, let us say you exceed the duration, you exceed the float, then another path becomes critical. So these kind of issues, it requires closer management of the network, and that is acceptable because you are using fewer resources. Okay, so we'll start the next class with a discussion on the floats you got on this and any questions you have on the floats. Okay, and how we would use the float to be able to see if there's any pattern or what we can do from project management perspective. Okay.